Good morning, students. Welcome to another section of mathematics class today. Today also we'll continue with the same topic what we have done yesterday. It's just extension of yesterday's class. Here we'll see two more types of question today. So here we go. Question is already there. See, if alpha and beta are zeros of the polynomial x square minus 4x plus 3, then form a quadratic polynomial whose zeros are 3 alpha and 3 beta. So today we'll mainly discuss two more type of questions based on the same topic. So this number one is one of those two type. So here polynomial is given to you and it is said alpha and beta are the zeros. So using this polynomial we want to form, question wants you to form a quadratic polynomial whose zeros are given. So again we need to form one more quadratic polynomial whose zeros are given here as 3 alpha and 3 beta. So remember, for this polynomial alpha and beta are the zero, or we can say alpha and beta were the zeros for this polynomial. Now using this thing we want to form a new quadratic polynomial whose zeros are 3 alpha and 3 beta. So here in examination they may ask any value. Here I use 3 alpha 3 beta. They may ask you 2 alpha 2 beta, 5 alpha 5 beta, like that. So it can be anything there. So let's see how to deal with such question. So solution. So first we'll let p of x as x square 4x plus 3. So this is the given polynomial. Now we know its zeros are alpha and beta. So we can write here, since alpha and beta are the zeros of px, so we can directly make use of that relation sum of 0 and product of 0. Okay, therefore we can write first sum of 0 as alpha plus beta, and we know it is b by a. Now we are familiar with that this a and b. So here if you see this polynomial here, and if we compare with the standard form, as I told you yesterday, this is the standard form of quadratic polynomial. So x square a, x has b, and c is the constant. So if you see here, x square, the coefficient of x square is 1. So we can say a is 1, coefficient of x is minus 4, so b is minus 4, and constant c is 3. So this can be substituted here. Now substitute, we get minus b itself is minus 4, so we can keep minus of minus 4. So here you should be careful while keeping this sign. A is 1 again, so we can keep 1. So this is minus into minus becomes plus 4 by 1 we can ignore. So sum of 0 we got 4. Similarly we'll find product of 0, alpha into beta. We know the relation c by a. C is 3, a is 1 again, so this will give 3. So we got both sum and product. Okay, now using these two values, the values of sum as 4 and values of product as 3, we'll go for finding a new quadratic polynomial having zeros 3 alpha and 3 beta. This is one way. There is one more way to find this quadratic polynomial. The other way is you can factorize here this polynomial, you can factorize and get the zeros. Okay, and whatever 0 you will get, we can keep here. So that is another way. So I will not go for that method, so this will be more convenient. So now once we get alpha plus beta alpha into beta, now we can go for the new the required polynomial. Now the required quadratic polynomial, so I can write directly polynomial, quadratic polynomial. Now the required polynomial having zeros, three alpha and 3 beta will be I can write here q of x, because px already I took earlier, qx. So we know that formula or that rule is x square minus sum of zeros x plus product of zeros. So this we know. Now remember one thing, here I wrote sum of 0, product of 0. So here we should be particular, we should know that this sum and product are not what we got here, sum and product. Why? Because this alpha plus beta or alpha into beta, alpha and beta were the zeros of this polynomial. Okay, now the polynomial which we want to find now, the new polynomial, its 0 are given as 3 alpha and 3 beta. Okay, so these are the zeros of the new polynomial. So this thing we should keep in mind. So now sum of 0, when I write, I cannot write alpha plus beta. I need to write 3 alpha and 3 beta. Okay, because these are the zeros of new polynomial. All right, and similarly product, this only we need to multiply. Okay, let's see. So x square sum of zeros means we need to add this 2, because these are the zeros. So 3 alpha plus 3 beta. Okay, x plus product of 0, so just multiply 3 alpha into 3 beta. Right, now if I'll write here only just x square, this one x square minus, now see here, if you see 3 alpha 3 beta, 3 is common, isn't it? 3 is common, so take it out. So when I take out 3, I'll be left with alpha plus beta, because these 3 are taken out. So I can write 3 alpha plus beta, x outside. Okay, plus this plus. Now here if I multiply 3 alpha and 3 beta, it's very simple, 3 into 3 will give you 9, 3 into 3. Alpha into beta will be alpha beta. Okay, so let me explain this step once again. So if you see here, 3 and 3, these are common. So whenever we find common, take it out. So I took this 3 out here, keeping alpha and beta within the bracket. Okay, so x there. Now here this multiplication, so don't get confused here, because I still remember some of you asked me this multiplication in class earlier. So that's why I want to give emphasis on this multiplication. So when we multiply any number, you don't need to multiply each of the term. Okay, so here what we need to do is number and number will multiply. 3 into 3 will get 9, and this alphabet alpha and beta will get alpha into beta. So it's not like that you will multiply 3 with 3 and 3 with beta, and again alpha with 3, alpha with beta. So that rule you should remember. So last time I still remember, some of you asked me this thing. So here, because in multiplication we don't follow that distributive law. Distributive law is true only for multiplication with addition, multiplication with subtraction. So we don't have that here, only multiplication is there, so we'll multiply this way. 3 into 3, 9, alpha into beta, alpha beta. All right, now if you see this part, what we find is alpha plus beta within the bracket and alpha into beta. So this also we can keep in bracket because bracket means multiplication only. 9 into alpha into beta. Okay, so here this particular thing, okay, alpha into beta and alpha plus beta, if you see, go back to your solution, if you see these two things already we found. See, alpha plus beta and alpha into beta, exactly these two things we found. These two things we found earlier. Alpha plus beta as 4, alpha into beta as 3. So we can substitute here from this. Okay, so this x square will come as it is, minus 3 will remain 3, bracket alpha plus beta already we found earlier 4, so I can give 4 with x outside here 9, alpha into beta we got here 3, so 9 into 3. So on further simplification we get x square minus 12x plus 9 3 27. So this is our required quadratic polynomial which they want us here to find. Then form a quadratic polynomial whose zeros are this. So using this zeros, 3 alpha and 3 beta, we found new quadratic polynomial. Okay, but remember this new quadratic polynomial we found on the basis of given quadratic polynomial whose zeros were alpha and beta. Okay, this is one way. This is what I feel convenient, so that's why I use this one. So as I told you earlier, there is one more way, that is you need to factorize this given polynomial, get the values of x, two values, definitely you'll get two values, those will be alpha and beta, and those alpha and beta you can substitute here in this form here. If you substitute whatever alpha beta you'll get there, you can substitute here. Okay, you'll get the same thing. Okay, so you can try when you sit for practice, you can try that way also, right? now let's move to the another question, same type. This is if you remember, I told in the beginning, today we will learn two more type of question on the same topic. Okay, so this one type we did. Now second question which I am going to tell you is not the second question is not of second type. Instead this is the same type as question number 1, only the slight change in the value. Okay, so it is same type only. Second type we will discuss little later. So here is the question. So here is the question, almost same, only the value you will find slight different there. If alpha and beta are the zeros of the quadratic of the polynomial 2x square minus 5x plus 7, see, it is same like number 1. Find the quadratic polynomial. In question number 1 it was told then form a quadratic polynomial whose zeros are this. So here it is same only, here it is said find the quadratic polynomial. See, it is same only, so we can easily make out. Form the quadratic polynomial whose zeros are, see, now this time is slightly different, 2 alpha plus 3 beta. Alpha and beta are coming together, and 3 alpha plus twice beta. Okay, so try to make out the difference between these two questions. In question number 1, zeros were 3 alpha and 3 beta, meaning alpha and beta were kept separately. So alpha only was one complete root, one complete 0. 3 beta was completely another 0. Okay, but in this question, unlike number 1, 1 0 is 2 alpha plus 3 beta, means it's a combination of alpha and beta. We can say it's a homogeneous a mixture of alpha and beta there. That means this is 1 0 this another 0. So we can um, think, we can take it as, we can assume it as this one as 1 0, means this whole we can consider as alpha and this one as beta. Okay, so this completely 1 0, this another 0. So when we use that formula, this formula to form new quadratic polynomial, so what we write, sum of 0. Now here we need to add the zeros. So in this step we will add both these two. Okay, both these two brackets, and when we go for the product of zeros, we usually multiply the zeros. Yeah, see, product of 0, this one and this one. So in this step we'll multiply this two bracket. Okay, this is slightly we can say a little bit longer than we can say bigger than the earlier one. Okay. Okay, you understood the question. The difference also I think you understood between this and this. So let's see. Everything approach will remain same. There's no change here. Same thing I will follow. Only that simplification part will be slightly bigger here, lengthier here. Okay, slightly lengthy. It makes no difference. So I'll give you enough practice work today. Yesterday, though I told you that I will send you some question, but later on I gave up because yesterday I don't know what happened. That session simply, no, it went west. It was west, we can say wasted session, poor session. So that's why I did not send any question yesterday. So today you will get enough question for your practice work. Okay. Yeah, what call that? Yes, whatever we did yesterday and whatever we'll do today, I'll send the composite question on both the sessions. Okay, so you try to do all those questions, and if you find any doubt, keep in touch with me. Okay. Yeah, approach will remain same. So I'll write here, let this is the polynomial. So px 2x square 5x plus 7. So once again, let me tell you, here also if you want, you can factorize this and get two zeros. Okay, alpha and beta, but I'm not going for that. I will follow the same rule what how we have done earlier. So I'll write, since many of you still confused, remember this one is therefore, and 2 dot and 1 dot down, 2 dots up, 1 dot down, this is since. Okay, so don't get confused. And the way of writing I'm showing you, this is how we usually write. So try to follow this. Okay, since alpha and beta are zeros of px, therefore I can write sum of 0 directly, right? Sum of 0, alpha plus beta, we know the formula, minus b by a. Now you know what is a, b, c here, a, b and c. This minus will come as it is. B is minus 5, so please take care of this sign. Sign is very important here. So many a time we ignore this minus, so this minus is required. B is negative here, minus 5, so minus 5 by a is 2. In earlier question a was 1, here it is 2, so minus into minus plus, it's 5 by 2. Product of 0, alpha into beta, it is c by a. C is 7, a is 2. So we got alpha plus beta as 5 by 2, product as 7 by 2. Okay, we got this. Now we'll go for the, okay, one second. Yeah, this part was hidden earlier. So alpha plus beta, we got 5 by 2, and alpha into beta, c by a, c is 7, a is 2, so 7 by 2. So we got both the what called relation. Okay, now we need the required polynomial. Okay, let's go for that. now the required quadratic polynomial whose zeros are, these are the zeros, 2 alpha plus 3 beta and 3 alpha plus 2 beta will be. So let me write again, q of x square minus sum of 0 x plus product of 0. Okay, now x square sum of 0, so these are the 0, remember these two are the zeros, this and this, so we will add this and this. 2 alpha plus 3 beta, I'll keep in one bracket, plus 3 alpha plus 2 beta, second bracket, and then whole bracket for this x, to keep x outside. So now we can say this is alpha plus beta, sum of two zeros, okay, sum of zeros, plus product of 0 will multiply again this bracket and this bracket, this 1 0 another 0, so 2 alpha 3 beta 3 alpha 2 beta. X square. Now simplify it, you'll get, if you open this and combine like term, 2 alpha and this 3 alpha, we can add them, so we will get 5 alpha 3 alpha and 2 beta, so we need to add, so again you'll get 5 beta bracket and this x, so here we can multiply them. Now here this term will give you, we need to multiply by distributive law, because there is a multiplication with addition, so this will multiply both, again this will multiply both, okay, so this will be a little lengthier here, so multiply 2 alpha and 3 alpha, 2 into 3 6, 2 into 3 6, alpha into alpha square, okay, plus 2 alpha into 2 beta, 2 into 2 4, alpha into beta is alpha beta, then now this will multiply both, plus sign, so we don't have minus, so we don't need to keep minus anywhere. 3 alpha into 3 beta into 3 alpha, 3 into 3 9, beta into alpha is nothing but alpha beta. Now 3 beta into 2 beta, do it, 3 into 2 6, beta into beta square, again this was hidden. It didn't come, what I did, 2 into plus 3 gives me 5 alpha, 3 beta plus 2 beta is 5 beta, so this was addition. Now here two brackets were kept with a plus sign in between them, so two brackets multiplying, these two are multiplying each other, so here we need to follow distributive property, 2 alpha will multiply both, again 3 beta will multiply both, so here I got, but it was hidden earlier, 2 alpha into 3 alpha, so 2 into 3 is 6, alpha into alpha square, then 2 alpha into 2 beta 4 alpha beta, 3 beta into 3 alpha, 3 into 3 is 9, beta into alpha is alpha beta, and then 3 beta into 2 beta, 3 into 2 is 6, beta into beta square, so this is what we got. Next step, this here 5 is common, take it out, alpha plus beta x. Now we can combine, here we get like terms here, 6 alpha square, 6 alpha square, keep them together, 6 alpha square, 6 and 6 we can take it out as common, plus this is 6 I took out, now beta square will be left, okay, this and this I combine last and this one, okay, 6 taken out as common. Now this one alpha beta like term. So 4 alpha beta plus 9 alpha beta, when you add them, because it's addition only, 3 and 4 and 9 will give you 13 alpha beta. Okay, next step, x square 5 alpha beta already we found earlier, so we can use little later. We need to simplify one more part. This part we need to simplify. See, alpha square plus beta square, this is a square plus b square. So if you remember this, what call this identity, this is an identity only, already I gave you in the class. So I'll write here, yeah, let me write here. It is of the form a square plus b square. If you see your note, you'll find 2 were there, so I will use plus 1, a plus b whole square minus 2ab. I will if you see that note, we wrote 1 plus whole square, another as minus, here minus whole square. Okay, so minus we don't need here because a plus b is nothing but alpha plus beta. So alpha, just in order to use alpha plus beta, and alpha is a into b means alpha into beta. Okay, so that's why we'll go for plus 1, the formula with plus 1, identity with plus, not with minus. Okay, so we'll make use of this identity here. Here alpha square plus beta square, it is a square plus b square, as I explained here. Right, 6 bracket, so I will use a plus b whole square means alpha plus beta whole square. Then minus 2ab, minus 2ab, a means alpha, b means beta. So this I'll keep in whole bracket. Why? Because 6 was there with alpha square plus beta square, so this whole should be multiplied with 6, and then 13 alpha beta. Now there is a reason for using this method, whatever method I'm following here. Why? Because in some other question we need to make use of this form alpha square plus beta square, a square plus b square, means this form. So that's why I kept this one, this process here. Otherwise this could have been done by the way what I told you earlier, by simply factorizing this one. If you factorize this by splitting middle term, you will get alpha and beta, and whatever alpha and beta you get, you just need to substitute here and here to get the new polynomial. But instead of that, I followed this method. Why? Because this is important. Okay, this part alpha square plus beta square, which is nothing but a square plus b square form. So in order to make use of this form, so that we should know how to use it, that's why I did this equation by this method. Okay, so here this may be a little lengthier here, but if you understand the concept, the thing will not be like that. Okay, let's proceed. X square, now keep this alpha plus beta x. Now here we need to open the bracket. Why? Because this is alpha plus beta means sum of zeros, alpha plus beta. Alpha into beta is product, so that's why we need to separate here. This is sum and this is product. Okay, so 6 will multiply this as well as this. 6 into this, 6 alpha plus beta whole square, then this minus 6 will multiply 2, is 12 alpha beta, plus this 13 alpha beta. So now this alpha beta you can combine if you want. Okay, you can combine them. 13 alpha beta minus 12 alpha beta is 1 alpha beta, means alpha beta only. So that also I'll show you here. So this 5 alpha plus beta x, this will be 6 alpha plus beta square, and this one, see, 12 minus 12 alpha beta plus 13 alpha beta. So plus 13 alpha beta minus 2 alpha beta is 1 alpha beta. So we can simply write alpha beta. 1 we can ignore. And 12 is big, 13 is bigger than 12. So this sign will be plus, that you know. Now the last step, this one, we got exactly in the required form. Now alpha plus beta is sum. Again alpha plus beta is square. Sum alpha into beta product. Now this bracket, and this last one, we can substitute the value alpha plus beta by 5 by 2, alpha into beta by 7 by 2. Just substitute here and you will get the answer. Okay, so this part I'll show you here. The same thing. So it is qx x square 5. So bracket, remember here, what was that? 5 alpha plus beta. Alpha plus beta was nothing but, if you see here, alpha plus beta was 5 by 2 and alpha into beta was 7 by 2. So this we will substitute here. Okay, so alpha plus beta was 5 by 2. So I'll keep 5 by 2 bracket. See, x, we have x, so we'll keep x here, then plus 6. Again we have alpha plus beta, but this time is square. So I'll write 5 by 2 with square, and finally plus alpha into beta. Plus alpha into beta. Alpha into beta was 7 by 2. So I can write here 7 by 2. So this will give x square multiply 5 into 5 is 25 by 2x. Here 6. I need to simplify this first. 5 is square, 2 is square, 5 is square, 25. 2 square is 4. 7 by 2. Here 6 and 4 we can cancel by 3 by 2. So x square 25x by 2. This is 3 times 25, 75 by 2 plus 7 by 2. Now we can take final LCM. LCM will be 2. 2, 2, 2. Here is 1, so it is 2. And 2 will multiply here. 25x plus 75 plus 7 by taking LCM. Next step, 2x square minus 25x. Now add them. This will give you 82 whole divided by 2. And we know here we have 0 because we are using 0 in this quadratic polynomial, zeros, right? So that's why this part is always 0. So this 2, when you multiply with that 0, become 0. So I can remove. So this is our final what called the polynomial. Okay, so this is a little bit bigger, we can say lengthier, but please try to learn this this particular solution. As I told you, this could have been done by that shorter way, by finding its 0, splitting middle term and putting those values alpha and beta here. That could be smaller, means steps will be shorter there, but this method, as I told you, why I use, only because of this one. Okay, alpha square plus beta square, this concept we need in and some other questions. And obviously when we go to question number 2, second type of question today, so there we will see this thing. So that's why I did. So don't worry about this lengthiness of this length of this solution. Try to understand the concept. Okay, so before going to the next form, I'll post a video here, then I'll make another video.